This is the 5th lesson of Unit 3. Okay, so we're going to work on this warm-up. So you should pause the video, do the warm-up, then play to check your answers. So the first problem here, we know that we have this first term and the second term. So we're going to figure out what the greatest common factor is. So I see x minus 5. I'm comparing cubed with squared. The greatest they have in common is squared. I see 2x minus 1 cubed, and to the 4th, the greatest they have in common is 3. So that's the GCF. After the GCF, we have parentheses. We're going to go one term at a time in order from left to right. So I'm looking here at the first underlined term. I'm looking to see what I have to multiply this GCF by to get that underlined term. The x minus 5 is squared. I need cubed, which means I need an additional x minus 5. The 2x minus 1 is cubed, and that's all I need. So I don't need any more 2x minus 1. So now there's a minus sign. And now I'm looking at the next underlined term. I'm done with the first underlined term. So x minus 5 is squared, and that's all I need. And 2x minus 1 is cubed, and I need to the 4th. So I need to subtract the quantity 2x minus 1 so that I'll have 2x minus 1, the quantity to the 4th. So now I can end my parentheses because I'm done with the second underlined term. So next I copy the GCF. I combine like terms. X minus 2x gives me negative x, and negative 5 minus negative 1 gives me negative 5 plus 1, which is negative 4. So I keep the GCF, and I can pull a negative 1 common factor out of that, which leaves me with x plus 4. I can either stop there and leave the negative 1 in parentheses in the middle, or I can bring the negative 1 out front. When I bring it out front, it no longer needs the parentheses. And that is my final answer. Number 2, grouping, no GCF. So grouping, now I find the GCF of the first group, which is x squared. I'm left with x minus 2. I copy the x minus 2. I figure out what x minus 2 needs to be multiplied by to give me negative 36x plus 72, and that's a negative 36. So I have two terms. The GCF between those two underlined terms is x minus 2. I'm left with x squared minus 36, which I see as difference of squares, so I'm going to go ahead and factor that into x plus 6 and x minus 6, and that is my final answer. Okay, so that takes care of the warm-up. Now, today's notes, we'll go right into those. Most of them are on the second page of the Unit 3 packet, so you'll need to turn there. And the first thing we did on that page was these 4 problems, which are part of number 1 on the top of the page. So it says to multiply, and you can either distribute using the distributive property, or if you want, you can distribute by using a generic rectangle if you find that easier. That's what I'm going to do. I'm going to make a 3 by 2 and label a plus b a squared minus ab plus b squared. And when I multiply a times a squared, that's a cubed. A times negative ab, that's negative a squared b. A times b squared is ab squared. B times a squared is a squared b. B times negative ab is negative ab squared. And b times b squared is b cubed. So we know we combine like terms. I have a cubed. Well, the negative a squared b and the positive a squared b, when I combine like terms, gives me 0. Same thing with the negative ab squared and the ab squared gives 0. So I just have a positive b cubed left. So when I multiply these together, the product is a cubed plus b cubed. Okay. Next, same idea. Y plus 5 and y squared minus 5y plus 25. Now, in class, I did have students do B, C, and D. So you should probably, if you're watching this, pause the video and try B, C, and D on your own, and then play to check your answers. So y times y squared is y cubed. Y times negative 5y is negative 5y squared. Y times 25 is 25y. 5 times y squared is 5y squared. 5 times negative 5y is negative 25y. And 5 times 25 is 125. So once again, we have canceling out happening, and we're left with y cubed plus 125. Next. So we have x minus y and x squared plus xy plus y squared. So x times x squared is x cubed. X times xy is x squared y. X times y squared is xy squared. Negative y times x squared is x squared y, a negative. Negative y times xy is negative xy squared. And negative y times y squared is negative y cubed. So when I combine those, the x squared y and the negative x squared y, the xy squared and the negative xy squared, and I'm left with x cubed minus y cubed. And lastly, part D, x minus 2 and x squared plus 2x plus 4. X times x squared is x cubed. X times 2x, 2x squared. X times 4, 4x. Negative 2 times x squared, negative 2x squared. Negative 2 times 2x, negative 4x. And negative 2 times 4, negative 8. So the 2x squareds and the negative 2x squared cancel out, the 4x and the negative 4x. And we're left with x cubed minus 8. Okay. So that takes care of multiplying. Then the next thing we talked about in class was the point of this lesson is to figure out what we noticed about the products. More specifically, eventually we're going to want to go the opposite direction. You already know how to multiply. This was just kind of practicing that to find some patterns. But eventually what we're going to want to do is start with a cubed plus b cubed and factor it. Okay, so in other words, so get that as the answer. And then same idea with the difference of cubes. This one's x cubed minus y cubed. If I start with that, how do I factor it? Okay, and so I told students to kind of figure that out, figure out what patterns you're noticing. So what we said for the first one, a cubed plus b cubed, we know that it factors into the quantity a plus b times the quantity a squared minus ab plus b squared. We know that because we just did it in reverse. We multiplied it out, but we got that as the product. Now we're starting with that as the product, and we want to get to the factors. Well, so the question is, how do we do that? The first thing that we can see very clearly is that a cubed plus b cubed is not a plus b, the quantity cubed. Okay, we didn't take a plus b times another a plus b to get a cubed plus b cubed. That is a common misconception. So be careful with that. It's not equal to, never will be. Okay, similarly, x cubed minus y cubed is not x minus y, the quantity cubed. Okay. On the other hand, we want to figure out how we would get the factors. So first of all, we're noticing, since we already know what the factors are, we're noticing, or you should be noticing, the first pattern is that the first factor will be a binomial. And the second factor will be a trinomial always. Every single one of these, whether it was sum or difference of cubes, was a binomial times a trinomial. So that's the first pattern that you should write down here. So then when I'm doing x cubed minus y cubed again, a binomial, and a trinomial. So the next thing, and again, I took a moment and gave students time to discuss these patterns that they were noticing. So these weren't things I told them, they were things that they picked up on. But the next thing that we picked up on was to get the binomial here, if I'm factoring a cubed plus b cubed, I take the cubed root of the first term. So the cubed root of a cubed is a, and the cubed root of x cubed is x. And that goes in the first spot for the binomial, the first term of the binomial. Do the same thing with the second term of the binomial, of the second term to get the second term of the binomial. So the cubed root of b cubed is b, and the cubed root of y cubed is y. Then we talked about the fact that, or students picked up on the fact that if it's a sum of cubes, like a cubed plus b cubed, then the binomial will be a sum. If it's a difference of cubes, then the binomial will be a difference. The other two signs, if it's a sum, it's going to always be plus, minus, plus. If it's a difference, it's going to be minus, plus, plus, always. Okay, and that you do have to memorize. You need to know sum is plus, minus, plus, and difference is minus, plus, plus. The next thing we picked up on, or the next pattern we noticed, was to get the first term of the trinomial, you take the first term of the binomial and square it. So a squared, and here x squared. Similarly, to get the last term of the trinomial, we take the second term of the binomial and square it. So b is squared, and y is squared. The last pattern that we noticed, again, we're disregarding the signs here because we already know this middle term is going to be minus for the sum and plus for the difference. So we're not paying attention to the sign, but the way that we get that middle term is we take the two terms of the binomial and we multiply them together. So a times b, again, disregarding the sign, just a and b, is ab. Here, x and y, disregarding the sign, x, y. And again, I'm disregarding the sign because I already know difference is minus, plus, plus. Okay, and that is how we factor sum and difference of cubes. Okay. So the next thing we did in class was we tried part 2, A through D. So again, take a moment, pause the video, try them, then play to check your work. So there's no GCF. I see sum of cubes, so I make a binomial and a trinomial. I see sum, so that's plus, minus, plus. I take the cube root of x cubed, that's x. The cube root of y cubed, that's y. I square x. I square y. I multiply x times y, and that's my factors. B, same idea, no GCF. Sum of cubes, binomial and trinomial. Cubed root of x cubed is x. Cubed root of 1 is 1. This is a sum, so plus, minus, plus. Square x to get x squared. Square 1 to get 1. 1 times x is just x in the center. C, same idea, no GCF. Difference of cubes. So binomial and trinomial. Cube root of a cubed is a, cube root of b cubed is b. This is a difference, so minus, plus, plus. Square a squared, square b squared, a times b, disregarding the sign, ab. Okay. And lastly, no GCF. Difference of cubes, binomial and a trinomial. Cubed root of x cubed is x. Cubed root of 8 is 2. It's a difference, so minus, plus, plus. Take x and square it. Take 2 and square it to get 4. And 2 times x, disregarding the sign, is 2x. Those are the factors. Next, B and C. I skipped A for a moment. Let's look at B and C. B and C are also sum and difference of cubes. So same idea, there's no GCF, binomial, and a trinomial. Cubed root of a cubed is a, cubed root of 27 is 3. Sum plus minus plus. Square a to get a squared, square 3 to get 9, multiply 3 times a to get 3a, and it's a minus because that was a sum. By the way, the trinomial will not be factorable, so you don't even have to check to see if it factors. It won't. And as long as we check for a GCF, neither of those terms should be able to factor. Okay, w cubed minus 1. Again, no GCF. I go right to difference of cubes. Cube root of w cubed is w. Cube root of 1 is 1. Minus sign because it's a difference. Minus plus plus. Square w. Square 1. W times 1 is w. Next, these two are not on the sheet, but I would like you to add them to your notebook and try them. We'll try this first one together, and then you can try the next one. So, no GCF, but I do see difference of cubes. So, binomial, trinomial. I take the cubed root of 8, which is 2, the cubed root of a cubed, which is a, so the cubed root of 8a cubed is 2a. I do the same thing with 27b cubed. The cubed root of 27b cubed is 3b. This is a difference, so minus, plus, plus. Now this is where you have to be careful. When I square the terms of the binomial, I'm squaring the quantity to a, not just a. So I get 4a squared. Same thing with the 3b. It's the quantity 3b that's being squared, not just b, not just 3. So 3 squared is 9, and b squared is b squared. So 9b squared is the last term of the trinomial. Lastly, we're going to multiply these two terms together to get that middle term. We already know the sign is positive, so 2 times a times 3 times b. 2 times 3 is 6. A times b is ab, so 6ab. Again, I already checked for a GCF, so I don't have to bother seeing if this factors. It won't. That's my final answer. So, pause the video, try this one. Okay, no GCF, sum of cubes, binomial times a trinomial. Cubed root of 64w cubed is 4w. It's a plus sign. Cube root of 125y cubed is 5y. When I square 4w, or the quantity 4w, I get 16w squared. This is a sum, so plus, minus, plus. When I square 5y, the quantity, I get 25y squared. And when I multiply 4 times 5 times w times y, I get 20w y. So we have 4w plus 5y times the quantity 16w squared minus 20wy plus 25y squared. And that is my final answer. Next, we'll go back to A and D, which we skipped A, so let's go back to A, and then we're going to do D and D. Now we have all these different techniques combined. So all the techniques that we previously learned, difference of squares, GCF, trinomials, factoring them, now we're going to combine that with possibly sum and difference of cubes. So when you see two terms and a minus sign, now you're going to have to be on the lookout for, is this difference of cubes or is this difference of squares? And also you still have to check for, is there a GCF as your first step. So looking at number 1, I check for GCF as my first step. I do see that 2x is the GCF. When I factor that out, I'm left with x squared minus 16. And oh, that's an old problem. We could have done that a couple days ago. We see difference of squares there. Okay. Now again, I'm not using difference of cubes because this is an x squared. Okay. Next, letter D. Again, we check for GCF. This is another old problem. We could have done this a few days ago. Half x is our GCF. Factor that out, we're left with x plus 5 times 1/2 is 5/2. And that does not factor any further, so that was strictly a GCF and we're done. Letter E. So I check for GCF, I don't see one. I see 2 terms and a minus sign. Previously, when we had 2 terms and a minus sign, it was oftentimes difference of squares, or it didn't factor at all. Now we have to check for difference of cubes as well. So when I see 2 terms and a minus sign, could be difference of squares, it could be difference of cubes, or it might not factor. So the way that I can tell the difference between difference of cubes and difference of squares is by checking the exponent. When it's a 4, it's always going to be difference of squares, or doesn't factor at all. When it's a 3 exponent, it's always going to be difference of cubes, or it doesn't factor. If it's a 6, it could actually be difference of squares or cubes, because I could have x squared being cubed, which is x to the 6th, or I could have x cubed being squared. Okay, so if it's a 6, that one's kind of difficult. It could be a cube or a square. We'll do some more of those in the next few days. But when it's a 4, it's going to be difference of squares, or it's not going to factor at all. And when it's a 2, difference of squares. When the exponent is a 3, difference of cubes. 6, it could be one or the other. If it's an exponent of 8, most likely it's going to be difference of squares. So most of the evens are going to be difference of squares, and most of the odds are going to be difference of cubes. But 6 is that kind of unusual one. So anyway, I just determined because the exponent is a 4, it's probably going to be difference of squares. So I'm not making a binomial and a trinomial, I'm making 2 binomials. And remember, difference of squares, square root, here, 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 and there. So square root of x to the 4th is x squared. Square root of 10,000 is 100. Count the zeros, 4 of them, so 2 and 2. 1 should be plus and 1 should be minus with difference of squares. Now remember, sum of squares, there is no such thing as sum of squares. It doesn't factor. So I keep the x squared plus 100. That does not factor. However, this is 2 terms minus sign. The exponent is a 2. That's difference of squares. So 2 binomials, x and x gives me x squared. 10 and 10 gives me 100. 1 being plus, 1 being minus, and that does not factor any further. That is my final answer. Okay, so you do have to be careful, be on the lookout for, now when there's 2 terms and a minus sign, could be difference of squares or cubes. To help determine which it is, pay close attention to the numbers and pay close attention to the exponents. Like I said, most times the exponents will give it away, but if it happens to be a 6 exponent, then you might have to look more closely at the numbers to see if they're perfect squares or if they're perfect cubes. Numbers meaning the constant is what I mean by that. 10,000 is not a perfect cube, but it is a perfect square, 100 times 100. So that was another hint that this was difference of squares. Okay, so that takes care of your worksheet, page 2 in the packet. So homework for tonight is what are called practice 1 and 2. Those are the next 2 pages in your unit 3 packet. So you'll see at the top of the 3rd page it says practice number 1, and the top of the next page says practice number 2. And that's what you should do for tomorrow for homework.